Hello dear friends, welcome to a class on significance of mean. In our previous video we have understood about the concept of significance of mean, concept of standard error of mean, concept of confidence interval, etc. Now we will look at the application of these concepts. Okay, so first we will try to solve problems related to significance of mean. First of large samples. I mean to say, we will learn how to find out the significance of mean in large samples when we have mean of large samples. Okay, so as usual, let us take a question and then try to understand how to do it. The question is, in a sample of 200 individuals, the mean score is found to be 60 and SD is 6. Test the significance of this mean. It means the sample is of 200, okay, 200 units. The mean of that sample is 60 and SD is 6, and we have to calculate the significance of mean. We have to find out the significance of mean, this mean, that is 60. Okay, so from the question we have the data that n is 200, and here symbolizes the size of the sample. Then m is 60, mean is 60, and standard deviation is 6. So the first step of for solving this question is to find out the standard error of mean. This formula you have already found in the our previous video. That standard error of mean is equal to what? Standard deviation divided by root over number of, or the size of sample. Okay, so here standard deviation is 6, n is 200, so it comes to be 0.42. Then look, like we have already said that there are, most of the time, or generally we look at the significance of mean at two levels of confidence. One is at 99% and another is at 95%. So that 95% is also called as 5% confidence level, and 99% is also called as 1% confidence level. So you may either write it as significance of mean at 95% confidence level or significance of mean at 5% confidence level. Now at 5% the value of Z is this. This we have again in the previous video we have understood how Z has come to be this. Okay, so as of now we have significance of mean at 5% is 5% means 95%. So at 95% the value of Z will be this. Now what we need is, let me clean this, 0.42. okay, SEM is 0.42, and at 5% confidence interval, because our Z value was what, plus minus 1.96 standard deviation, and SEM was what, I have rewritten these two things because in the board I have rubbed those things. That's why I am writing these things again. Okay, you need not write these two things again. Okay, because you have written it already. So our SEM was how much? 0.42. Now what we need to find out is, we need to find out X. In the unit of NPC also we have used this formula, okay, but here it is a little bit different. X is equal to M plus minus Z, and here we use standard error of mean in place of standard deviation. Okay, if you remember in the NPC unit we used the same formula, similar kind of formula, where X is equal to M plus minus Z into standard deviation, correct? But here our standard deviation would be standard error of mean. Now let us put the values. M is 60 plus minus Z is 1.96 standard deviation, and SEM is 0.42, correct? So 60 plus minus this comes to 0.82. This you understand, no? Plus minus is both side of NPC, correct? This side is minus, this side is plus. Okay, so plus minus, we need two values, no? You understand it from the previous video. So now let us we have two values, no? Now both the sides, from plus minus both the sides, we have two values. So let us break these two things. 60 plus 0.82 and 60 minus 0.82. So it comes to 60.82, 60.82, and this comes to 59.18. Okay, these two are our limits at 5% interval. So how to write this? We will write at the end, or you may write after finding out at the 5% level. You can write the interpretation here also, or at last also. So these are the two limits for our what? For the confidence level at 5%. Now let us go to 1%. Okay, let us go to 1%. Same thing we will write again. Now we will write significance of mean at 1% confidence interval. Okay, so at 1%, what happens? The value of Z is, the value of Z is plus minus 2.58 standard deviation, correct? This you remember from the previous video again. So x is equal to m, let me take the space of the board. Therefore x is equal to m plus minus z into standard error of mean. Mean is 60, so plus minus z will be 2.58 and standard error of mean was 0.42. Now 60 plus minus 60 plus minus, this becomes 1.08. Okay, so let's break it again. 60 plus 1.08 and 60 minus 1.08. This becomes 61.08 and this becomes how much? 58.92. Okay, these are again two limits at 1% confidence interval. Now this, we have calculated our values. Now we will write the interpretation, which is a very important part when you are solving questions like this. Okay, so let us go to that one. How to write the interpretation? We will write, thus it can be said that there are 95% chances that mean of population would fall between limits 59.18 to 60.82 and 99% chances that mean of population, this you remember, no? Mean of population would lie between 58.92 to 60.82. 61.08. Okay, now you can understand, no? Look, though we did what we did, we plus and minus we did, and we got these two values, correct? Now what we have done at 95%, where we calculated at the 5% confidence interval, we have written that there are 95% chances that mean of population would fall between these two limits, and mean of population would lie between these two limits at 99% or 1% confidence interval. So this is the result of our solution. Okay, so this is how we have said that we are this much sure, we are 99% sure that mean of population would lie between this and that. At 95% we have said that the mean of population would lie between, we are 95% sure, we are 95% confident that mean of population would lie between 59.18 and 60.82. Okay, this is all about significance testing, how to test significance of mean at two particular confidence intervals. Okay, so I hope this video will help you to learn how to calculate the significance of mean at two confidence intervals. Thank you.